Welcome back everyone to my channel. Welcome back to another video in the computer organization course. So today we'll be focusing on converting from binary to octal. I think it's very important and it'll be very important in the future videos of this chapter. So let's get started. So how do we convert from binary to octal? The way we convert to binary to octal is we have to use 3 digits. We have to separate the binary numbers into 3 digits. And why do you say 3 digits? The radix of octal, the radix of octal equals 8. So what powers of 2 equals 8? 2 to the 3 equals 8, and that is why we use 3 digits. But let's show you even more. So let's say it's 0, 0, 0, right? This value, when adding the powers of 2, 2 to the 0, 0, 0, and 0. But let's say it's all ones. 2 to 2, plus 2 to the 1, plus 2 to the 0. Think about it as being 2 times 2 times 1 plus 2 to the 1 times 1 plus 2 to the 0 times 1. Because these are ones, it allows us to add these values and find the sum. So this one over here, the value of that is 7. But the value over here, let's say it's 2 to 2 times 0 plus 2 to the 1 times 0. And 0 times 0 is 0. So the value of this would be 0. We can have any combinations of 3 binary digits that we want. But the lowest value of binary is 0, 0, 0. And that value shows to be 0. But let's say it's 1, 1, 1. The highest value of 3 binary digits is 7. So what is the numbers from octal to what is the radix of octal? The numbers that are allowed in octal is 0 to 7. That is why we use 3 digits, and that's why we use this way, so we can make sure we have the correct digits from 0 to 7. We're not having 8 or 9 or A, B, C, D, E, F. We just have the values that we need and that we can use for octal. So let's do a little stop talking and I'll show you exactly what I mean. What I like to do is separate it so there's a clear distinction. So I'm just using these numbers over here. I'm separating these 3 digits right here, these 3 digits, and then these 3 digits. So we always start from our origin point, 2 to 0, 2 to the 1, and 2 to the 2. Same thing for this one. We are not shifting the values of 2's. We keep the same 3 values, the 3 sums of 2, the 3 powers. Alright. And now we try to figure out which ones are 1's. So this is a 1, and this is a 1. So it's 2 to the 2 plus 2 to the 0. Or you can look at it as 2 to 2 times 1 plus 2 to 0 times 1. But this is a little bit too much. All you have to know is how to do it this way. And over here, this is a 1. So it's 2 to the 0. So what are the values over here? 2 to the 2 is 4 plus 1. And over here is 1. So we have 51. We join these numbers together. And the value of 1, 0, 1, 0, 0, 1 in base 2 is 51 in octal form. There you go. Now for the next one, we're going to do the same exact thing. So we have 1, 1, 1, 0, 1, 0. So what we're going to do is we're going to separate 3 digits, So 2 to the 0, 2 to the 1, and 2 to the 2. 2 to the 0, 2 to the 1, and 2 to the 2. So over here, for the 3s, we get hits on all of them. 2 to 2 plus 1, times 1. Same for this one, same for this one. So what we're looking at is 2 to 2 plus 2 to 1 plus 2 to the 0. But on this right side, these right 3 digits, what we have is 2 to the 1. And remember, these are separated. So we have 7 over here, because 4 plus 2 plus 1. And then we have 2 over here. So what our value in octal form, in binary form, it's 1, 1, 1, 0, 1, 0 in binary form. But in octal form, it's 72. We join up these numbers. Alright, and that's what it is in octal form. Let's do the same thing. Separate it into 3 digits. So what we're looking at is 2 to the 0 up to 2 to the 2 right here, and 2 to the 0 up to 2 to the 2 right here. This matches up to the 2 to the 2, and this matches up to the 2 to the 0. So what we're looking at is 4. You have that separation, and 1. So 1, 0, 0, 0, 0, 1. In base 2 is 41 in octal form. Let's try this one more time, and it's the exact same thing for fractions, and keep the same way the 2's go. Do not flip the do not flip them. I'll show you what I mean by flipping them. So we have the decimal form, 0, 0, 1. So you see how this goes 2 to 0, 2 to the 1, and 2 to the 2, going this way. It's the same exact thing for fractions. And 2 to 2 goes this way. Alright? So, for example, if we have another 1 here, let's say we have another 1 here. This is going to contain to its own 3 digits. You're not going to start it from over here. Just make sure you start the first 3 digits from over here and count 3 digits, and then we have the correct sum of powers on the rightmost bit. So let's ignore this right over here. So what is the answer? So we have 2 to 2 plus 2 to the 1. Then we have our decimal, and then this 1 matches up to 2 to the 0, which is 1. So what we have is 6.1. So 110.001 in binary form is 6.1 in octal form. Same thing over here. We are doing the same exact thing. So this matches to 2 to the 2, 2 to the 0, 2 to the 1, and 2 to the 2. There you go. There you go. Same exact thing. So what we're looking at is 6 right here, because 4 plus 2. And then what we're looking at is 4 plus 1. So you're looking at 6.5. So 110.101 in base 2 is 6.5 in octal form. And for the last one, I had made sure to do the hardest one as I could. It's not super difficult, but it's definitely more tedious. So we have our 3 1s, our 101. We're just making sure to separate them into 3 bits. 0, 0, 1. We have our decimal place. Then we have 110. 110, 010, and 001. Alright, same thing as always. 2 to 2 plus 2 to the 1 plus 2 to the 0. Over here it's 2 to the 2 plus 2 to the 0. Over here it's 2 to the 0. 2 to the 2 plus 2 to the 1. over here is 2 to the 1, and over here is 2 to the 0. So what happened? These correctly line up with each other. These line up with each other. These line up with 2 to the 0, 2 to the 2, 2 to the 1, 2 to the 1, and 2 to the 0. So this value right here is going to be 7 because it's 4 plus 2 plus 1. 4 plus 1, so this is 5. This is 1 decimal. And here what we have is 6. Here what we have is 2. And here what we have is 1. So 1, 1, 1, 1, 0, 1, 0, 0, 1, decimal, 1, 1, 0, 0, 1, 0, 0, 0, 1. In base 2 is 751.621 in octal form. And there you go, guys. So, well, thank you guys for watching. If you guys want to hear from me again, please leave a like, comment, and subscribe for some more educational content. There will be more computer organization courses and more C courses. But if there's something in specific that you want to see, please let me know. Have a blessed day.